The universe looks like a big, empty ocean with a few galaxies here and there. But this is just a trick. Only a small part of all atoms are thought to be in galaxies. The rest are thought to be floating in the space between galaxies. Gas spreads out from each galaxy like the roots of a big tree, and gravity pulls in more matter to add to this dense forest of galaxies. Here in the intergalactic medium, hydrogen and helium are woven together into sheets and filaments that flow into galaxies and finally form stars. But if we take a closer look, we can see who is really in charge. Quasars are the most powerful things in the universe. Compared to the Amazon River, they are as small as a grain of sand. They live in the centers of some galaxies, where they shine with the power of 1 trillion stars, shoot out huge jets of matter, and completely change the shape of the universe around them. They are so strong that they could destroy an entire world. What are they, and how do they change the way the world works when they want to? Strange things are happening in the sky everywhere you look. In the 1950s, scientists saw strange, loud radio waves coming from many different places in the sky. They were called quasi-stellar radio sources, or quasars, because they looked like dots of stars but could only be seen through radio waves, not visible light. They were strange in every way. Some flashed, and others sent out both radio waves and high-energy X-rays, but they all seemed to be very small. They also moved very quickly, up to 30% faster than the speed of light. The only thing that could explain it was that they were so far away that the growth of the universe was making them move away from us. But because they were so far away, quasars couldn't just be stars. Instead, they had to be the busy centers of galaxies billions of light years away. And it gets crazy. Given how far away they are, they must be thousands of times brighter than the whole Milky Way for them to look so bright and loud. Monsters that exploded and screamed into the void with a level of fury that had never been thought of before. When we made a map of the sky, we found more than 1 million quasars. And all of them seemed very far away. When we look into space, far away means very long ago because it takes so long for their light to reach us. The number of quasars was at its highest 10 billion years ago, when galaxies and the universe itself were still very young. Let's go back in time to just 3 billion years after the Big Bang and see what was going on. How powerful quasars really are. How could a galaxy that is still young be so bright and violent? There weren't nearly enough stars for all that light and radiation to come from them. And since galaxies tend to get bigger over time by joining, the light from stars and small galaxies shouldn't be much brighter than the light from any galaxy today. There is only one way to make quasars shine with so much energy: feed them to giant black holes. We still don't know how they came to be, but every galaxy seems to have one in the middle. But how can black holes, which trap everything that crosses their event horizon, be the greatest things in the universe? Well, a quasar's light doesn't come from inside one of these black holes. Instead, it comes from a huge disk of gas that orbits around them. This is called the accretion disk. Matter is what makes both stars and quasars shine. It's just that black holes are the best machines in the world for turning matter into energy. Matter dropping into a black hole can release up to 60 times more energy than nuclear fusion in the center of a star. Because a black hole doesn't get its power from nuclear processes, but from gravity. Before crossing the event horizon, matter that is falling into a black hole speeds up to almost the speed of light. This gives it a huge amount of kinetic energy. Of course, it takes that energy with it once it goes into the black hole. If you drop your matter in the right way, you can see this energy. If you fall straight down, nothing will happen in the outside world. But when there's a lot of matter, it moves toward the event horizon in a very fast spin, making a disk. It gets hundreds of thousands of degrees hotter when particles hit each other and rub against each other. In an area not much bigger than our solar system, the center of a galaxy can give off more energy than all of its stars put together. This is what a quasar is, a very large black hole eating a lot of matter. The black holes also eat a lot. Most quasars use up between 1 and 100 Earth masses of gas every minute. 10 billion years ago, the universe was about a third of its current size, so the intergalactic medium was much less spread out. This meant that the strands of gas around quasars could feed them a feast, making them throw up crazy amounts of light and radiation. The biggest quasars power jets by twisting the magnetic field of the matter around them into a narrow cone. Like a particle accelerator, they send out huge beams of matter that crash through the circumgalactic medium and grow into plumes that are hundreds of thousands of light years long. It's almost too big to understand. A tiny spot in a galaxy is cutting out 100,000 light-year-long pieces of the universe. But quasars can only eat for a short time, maybe a million years, because their feast kills their galaxy in the long run. How quasars kill galaxies? Okay, maybe killing is a bit of an exaggeration. After its quasar goes out, a galaxy is still there. It won't be the same again, though. Quasars are some of the largest and hottest things in the universe. When they heat up their galaxies too much, they stop new stars from being made. Stars can't be made from hot gas. This seems strange, because stars are made of gas that clumped together and got very hot. But atoms move quickly in a cloud of gas that is already hot. When they hit hard, putting out pressure that is stronger than the pull of gravity. This keeps hot gas from forming stars. Instead, the best gas for making stars is already cold, so it won't fight becoming a star when the time comes. Besides that, quasars push gas out of the galaxies they are in. Not only does this weaken the quasar, but it also takes away the building blocks for new stars from its galaxy. Even though this sounds sad, it could be good for life. Too many stars can be a much more dangerous option. Massive stars usually explode in supernovae after making new stars, so planets would be burned and unable to make children. But, of course, it's not that simple. Like our planet's biosphere, which is a complex system, every part of the galaxy depends on and affects every other part of the galactic atmosphere. Hot things like quasars and supernovae tend to push gas out of the galaxy, but shockwaves and quasar jets can squeeze gas and make new stars, at least for a short time. And the gas that goes out will mix with the gas that comes back in, making it go around the galaxy again. But in general, we can say that if things hadn't calmed down, we wouldn't be here today. This brings us to our last question. Did the Milky Way used to have a quasar? It's not clear if every galaxy went through a quasar phase, but learning about faraway quasars could help us learn about the Milky Way's past. Galaxies don't do a good job of keeping their past alive. The constant swirling mixes up the clues to their past like sand on a beach. It's possible that the Milky Way was once a quasar, which may have allowed our giant black hole Sagittarius A star to grow to 4 million times the mass of the Sun. But we don't know much about its past. Even though Sagittarius A star is sleeping now, it could become a quasar in the future. In a few billion years, the Milky Way and the Andromeda Galaxy will join together. We've seen more than 100 double quasars, which are created when two galaxies crash into each other and send new gas to the black holes in the middle. It won't last long though. When galaxies merge, their supermassive black holes fall into the middle of the new galaxy, sending dust and stars in all directions. We don't know if this will happen or not, but it would be an amazing sight if it did. Maybe some beings from a long time from now will see it and be amazed by what they see.